Welcome to SST College of Arts and Commerce. This is SST Edupedia. Myself Jyoti Sardar. Today we will be talking about the UML diagrams, that is part 2. In the earlier session we have covered few UML diagrams. We have given the idea, that is what is UML. So UML is basically the standardized way for drawing various diagrams required for the project to be developed. So let us see the first diagram, that is the activity diagram. Here we will see that there are various activities that are going to be carried out inside a project. So an activity will be having somewhere the start and the end. For example, over here the person is giving some order. So the order is requested. There will be some receptionist or some end user who will receive the order and then fill in the details, and then the order will be given to the shipping department. Then the order will be closed. So that's how we will say the activity diagram can be in that case drawn. This is also the way we can draw the activity diagram, which will involve the various actors, that is stakeholder, requirement analyst, and then the enterprise architect. Next diagram that we say, that is the state machine diagram. So it can show the various states of an entity, also how an entity responds to various events by changing from one state to another. The history of an entity can be modeled by a finite state diagram. So finite state diagram, that must be studied under the TOC topic, that is theory of computation. We will say here the objects will be in one or the other state, and then it will move to another state. So for example, the product is going to be ordered by the customer. So it is in the state, that is it is about to be ordered, and once the order is placed, then the order has to be thoroughly verified by the backend, and then the order will be given for the shipment and then ultimately delivered to the customer. So this is a simple diagram where the order or a simple dial phone is going to be given an example. So when we say we need to dial a phone, we start dialing the number and then we do a task of receiving the call, and then that's how the entity stops. Same, the next diagram, that is an enrollment of a student to be done for the exam. So he will be obviously first taught and then his exams will be taken up, okay, and then after his first term starts, he will be taught and then his exam will be conducted by allowing him to fill the respective form. Next diagram, that is nothing but called as the use case diagram. It describes the behavior of the target system from an external point of view. Use case describe the meat of the actual requirement. Use cases, a use case describes the sequence of actions that provide something of a measurable value to an actor. An actor is a person, an organization, or an external system that plays a role in one or more interaction. Associations are between the actors and the use cases that are indicated as a solid lines. See, use case basically depicts the scenario of a subsystem, or of you can call it as a program, or two or more programs we can combine. So basically use case is nothing but an activity that is going to be performed into the system to do a particular task. Then in that system there are various actors involved. So actor, as said, it can be a person, it can be an organization or an external system. Let's see the diagram. Actor is denoted with a stick figure, that is here patient is an actor, and then he is taking an appointment in order to visit the doctor. Second use case diagram, where a customer is going to place the order. So before the customer is going to place the order, he will check whether the order is or the product is available. After the product is available, he will place the order. Shipping clerk will fill the details. Salesman will accept the order, and then once the order is placed, the payment can be done by the customer. So The telephone catalog is an automation over here. The boundary stick figures are the customer, salesperson, shipping clerk, supervisor, and at the center we have the activities which are drawn in the ovals, or it is also called as the use cases. This is another diagram where we have student taking some loan and then asking the permission for that. So he is taking the loan from financial institution and then he is then obtaining the loan. He also have to repay the loan, okay, and then by that he will be able to pay his fees. Next, the sequence diagram. It models the collaboration of objects based on the time sequence. It shows how the objects interact with others in a particular scenario of a use case. So we say that a sequence diagram can be drawn for a use case. It is nothing but the interaction that takes place between the objects. So over here there are three objects that are there, that is the student, seminar and the course. The student is going to enroll for the seminar. For that he has to place a request. So once the request is given, he is going to enroll for the seminar which is going to be conducted of a particular course. Then the details that are going to be retrieved, that is seminar history and whether the student is eligible for attending the seminar, and then the status is written whether the enrollment is allowed or not, or allowed enrollment is done or not. So dotted line is nothing but that much time your object is going to be remain active, and then seminar the vertical line says that, vertical box says that much time the object is going to be alive. UML diagram history is as follows. We've already talked about this two types of diagrams that we draw, that is structure chart and then the behavioral diagram. Now let's see the various symbols used in the various diagrams. So first diagram, that is use case diagram. It has three symbols used in it. That is first symbol, that is actor symbol. Next symbol, that is the use case. So use case is basically the activity, and the third one is a relationship. So inside the relationship it will be again the straight line connecting between the actor and the use case, or it will be the extends relationship or the includes relationship. Let's see one example of includes relationship. It also has the extends relationship. For example, if the driver is going to drive the vehicle, then he'll have to do a task of starting that vehicle. It will also include what? The vehicle, when he is going to drive, he is going to make use of accelerator, he is going to make use of steering, he is going to make use of the brake. He also will have to park the vehicle at some particular place. So park will also include somewhere brake. So includes, in that case the relationship is denoted with the dotted arrow, and on the arrow we write the keyword specifically, that is the includes or the extends. This is also the example of the extends keyword. When user is trying to search something, that is he is trying to search his friend on the Facebook, then he is going to send the request once he found his friend, and then that friend may use this friend request or he may deny this friend request. So we can say extends the relationship will be used in this diagram as above. Okay, next symbols that are used, that is the sequence diagram symbols. Then in sequence diagram symbol, lifeline is very important. So how long that particular object is going to be available. Then the actor symbol, who is involved into that sequence of actions. There is going to be a message that is going to be exchanged between various objects. So that is denoted with an arrow, and then next the activation bar. So that's a vertical bar. When a message is going to be sent, that message will be sent between the objects, and vertical bar will be created, and that bar is called as the activation bar. Next, the state machine diagram. So state machine diagram has the initial state, the state box, then the decision box and the final state. The decision box is simply a question mark, and then depending on the question there will be yes or no as a separate state change symbol. Again, simple example of a state machine diagram. When the person is trying to access an ATM system, he is also allowed to enter somewhere the OTP. OTP is validated, so that's how the user authentication will be done. Next, the class diagram symbol. So class diagram symbol has the rectangle, which is divided in three parts. First the class name, next the attribute, and then the operations. The class diagram also has the cardinality to be denoted, which is going to be like 1 to 1, 1 or more, exactly 1, 0 or 1, or 0 or more. So that is how the classes will be related with each other. So whether there is a relationship that is going to be there between the classes, so that relationship is between whether one class is related with another class in exactly one manner. Next, this is also the type of relationship that exists between the two or more classes. That is first one, that is an association. So associations are the relationship between the classes in UML diagram. Interface, that is one class may inherit the properties of another class, that is one class may try to use another class, so that is your inheritance relationship. Then the realization, so in realization it is a blueprint between the class and the object containing its respective implementation level details. Next, the dependency. So an object of one class might use an object of another class method. Next, aggregation. So it is again a special type of association which is called as a part of relationship. Then the component diagram. So component diagram again denoted in the rectangle, and then there is a dependency shown, that is between the you can say as a dotted line. There are various type of components that are there, that is the component may be the database, it is set of files or authentication files. Then this is how the UML hierarchy is going to look like. That's all everyone. Thank you.